All right, so this will be the last video of this little section here. I just wanted to again mention that it's the electrons, these, very tiny charged particles that are moving around in these circuits, and the positive things like protons, the positively charged particles are much more massive, almost 2,000 times more massive than electrons. But they're also bound to the nucleus by the strong nuclear force, and the electrons are much more loosely bound to the atoms by the Coulombic force that we've been talking about. And so when an external electric field is present, it doesn't take much to cause the electrons to move, because that electric field, the force from, the electromotive force, which we're going to talk about, which is voltage, can easily move the electrons through something like a conductor. The protons are fixed. They're much more massive, and they're bound to the nucleus much more strongly than the electrons. And so I think that's important to note. And what's also important to note is that in the voltage sources, which we're going to talk about in the next section, we're going to talk about voltage, we're going to talk about current, and we're going to talk about resistance, because those are the three quantities that really matter when you're doing DC circuit analysis. But what's important to note is that what a voltage source does, we talked in the previous video about this electric field that is, present due to the charge imbalance. There's a charge imbalance between this positively charged region here and this negatively charged region here, right? That the charge imbalance meaning that there's a discrepancy between the charge between these two regions in space, and that's what gives rise to the electric field. Once this is neutralized, there's no more electric field, right? This region is now at net neutral. So any other charge that you drop out here, if you drop the plus charge or you drop the minus charge, there's, at least from this region, there would be no field acting or any force acting on these particles, because now this region is neutral. It's not going to repel, it's not going to attract, it's not going to interact whatsoever. And so what the job of a voltage source, when it's providing power to an electrical circuit, is to maintain this charge imbalance, okay? And so, and that makes sense. If I want this region to be a positively charged region, and I want this to be a negatively charged region, you might start to imagine that as electrons leave this region, then this charge is going to increase from some negatively charged value up till it reaches zero and it's neutral. And as I pump electrons into this positively charged region, then I would have this positive charge dropping as I add electrons all the way down until it reaches zero, and then everything's neutral. And so the job of the voltage source, a battery, a power supply, whatever it is in our circuit that's providing power or providing energy, is it's using some electromechanical or chemical mechanism. Batteries specifically are electrochemical. It's using some mechanism to maintain this charge imbalance, so that field, that electric field, I'm going to go ahead and switch to the next slide, that field right there can be maintained, and that we can continue to have electrical charges flowing from the region of negative charge to the region of positive charge. And in a circuit, what I have, and I drew this previously, is I have a voltage source, which we're going to talk more about again in the coming lectures. But I have this voltage source, and I'm going to connect it to some kind of external circuit here. This will be my external circuit. And if I make sure that this region stays positively charged and this region stays negatively charged, now I can have electrons that are going to flow from the negatively charged region through the external circuit and then back to the positive region. And that is how I power a circuit. That's what a voltage source's job, the job of this source here, is to maintain that charge imbalance so that electric field will persist, the voltage will remain constant, and I can have current flowing through my circuit. And that is how energy is delivered, and that's how we do work. That's how you do electrical work. Someone might ask, well, why don't the charges just flow through the battery this way? And that's a great question. There is definitely going to be some sort of mechanism inside the battery that separates the negative terminal from the positive terminal and will not allow electrons to flow in this direction. It would be either a separator in a battery or some other sort of insulator that will prevent charges from flowing this way. And so the only choice is for the charges to flow this way in order to, react to this electric field that is presented by the battery. Okay. And this is, we're getting into some deep topics here. This is how circuits work. I want to mention again, I've probably mentioned this already, that this is not the level that we're going to be analyzing circuits at. We're not going to be analyzing them at the electron level. We're not going to be analyzing charge, and we're not going to be analyzing fields. What we really care about are things like voltage, current, and resistance, and that's what we're going to introduce in the next video. But I think it's really important to be able to wrap your brain around what we're talking about when we talk about current. What is current? Current is the flow of these charges. What is resistance? Resistance is the material property that wants to prevent those charges from flowing, and then voltage is the force that's actually pushing the charges through the circuit. So that's what we're going to talk about next. Obviously, if you have any questions, please reach out via the discussions, and I'm going to go ahead and end this video here, and then we'll move on to the next section.